All right, we continue with the uncertainty in measurement. In the previous video, I have explained to you how to use or how to consider uncertainty in reading trends. Be careful, not all data result in the graph that's showing decreasing or increasing trend is actually decreasing or increasing trend until you consider the uncertainty itself. And you can watch the previous video about that. Now, how to actually generate the uncertainty? Well, again, uncertainty mean the inability of a apparatus of measurement to measure the exact actual true value of a measurement. So it is actually the uncertainty value is actually usually written in the apparatus itself, or simply you go for the analog measurement is the smallest measurement divided by two. So for example, if you have balance, digital balance in here, uh, there is usually written in there what is the uncertainty of the measurement. For example, if it is written 0.1, it means every measurement will be plus minus 0.1. So for example, oh, I want to weigh 5 gram of something in there, okay, and then there is the scale, yeah, here, sorry, there's the scale, okay, 5 gram, and then usually it's written or we calculate by ourselves the uncertainty of this. For example, the uncertainty is 0.01 gram. So it means you check. Usually we have to check the box of this digital balance. When you bought the digital balance, of course you have like the box or manual book. There is in manual book what is the uncertainty of this digital balance. For example, in here, let's say in the manual book say this is 0.01. So it's mean every time, then if you then later on, okay, I want to weight 5 gram, then you weight this, for example, you want to weight salt lah, yeah, and then salt is 5 gram. After it's showing in here in the scale 5 grams, and then you go 5 gram plus minus 0.01 gram. Well, it's not 5, then 5.00, because it's two decimal places. Sorry, 5.00 gram, something like that. So it means um, your 5 gram is actually not 5 gram. What you can have is actually ranging from 5.01 gram, uh, and then the lowest will be 49, I guess, 4 point, I guess, 99 gram, because 5.00 minus 0.001, right? 0.001, yeah. I think that's 4.99 grams. So that's the range again. That's what you have. Remember, the value of 0.001 usually available in the manual book of the apparatus, or you can, for this is for digital, yeah, for the manual analog measurement. For example, you have rulers and stuff. You basically divided the smallest measurement by two. Okay, so that's the first measurement, and it's every measurement generate its own uncertainty. Now, let's take a look at the other number two. It's said in here the absolute uncertainty versus the percentage of error. Actually, not percentage of error; it's just percentage of uncertainty. So percentage of uncertainty. So absolute error is the value itself. So for example, when you have 5.00 gram plus minus 0.01 gram, so this is what we call it as an absolute uncertainty. It always refers to the actual number of uncertainty. But the percentage, of course, it's percentage of the uncertainty itself. So for the percentage of uncertainty will be, the formula will be the absolute divided by value, data value, times 100. So the percentage of uncertainty will be 0.01 gram. This is the absolute. And then divided by the value of our measurement is 5 grams. So 5 gram times 100. So it's going to be, I think, 2%. Yeah, right? Yeah. No, 0.2. Oh my God. 1 divided by 5, 0.2. Yeah, 0.2% of uncertainty. Okay, so now how then we propagate our uncertainty? I mean, maybe after you weigh this 5 grams, and then the procedure say heat, for example, weight, and then heat, and then re-weigh, okay, and then uh, the weight in here, the first one is 5 grams, so 5.00 gram plus minus 0.01 gram. After heating, for example, it becomes 4.54 gram plus minus 0.01 gram because it's using the weight, the same balance lah. And then, for example, you want to find the delta or the mass change before and after heating. So in here, the delta mass, for example, delta mass is, for example, mass initial minus mass final. Of course, what you need to do is, initially it's 5 gram and then minus 4.54 gram. So the delta will be 4 point, I don't know, sorry, it's gonna be 0 point 46 gram, correct? 0.46 gram is the change in mass after heating. How about the uncertainty? Okay, how to calculate the uncertainty of this? Okay, so if you do, this is the key. If you do addition or subtraction, then you need to also add uncertainty. So for this operation, you need to add the absolute uncertainty. Okay, so the absolute uncertainty is 0.001. So you go, then in here you're going to be 0.001 plus absolute uncertainty of the weight after heating. So the total will be 0.02 grams. So plus minus 0.02 grams. So remember, when you do addition or subtraction to the value, the uncertainty need to be added as well. But for example, in the next case, you have uh, you have to, okay, I want to divide the delta mass, for example, with, you have to divide, yeah, so divide with let's say time, because you want to, oh sorry, not time, for example with other mass lah, ya, or, you want to divide the delta m with the sample mass, so you will know the percentage later on. So for example, my delta mass in here is 0.02 gram. I want to divide it with the initial mass because I want to know how many percent of them is evaporated. So of course this is gonna be uh, sorry, not 0.02, 0.46, 0.46 gram. This is the value, delta mass, and then divide. For example, I want to divide them with the initial. So if you divide or multiply value, then the uncertainty, you have to uh, add the total percent of uncertainty. Okay, so you cannot use, well, yes, we know if we generate one by one, yeah, the uncertainty of this guy over here will be plus minus 0.02. As you can see in here, the 5 gram, the uncertainty is plus minus 0.01 gram. You cannot add directly. You cannot. Okay. So what? Because this is a division. If it's subtraction or addition, yeah, you can just directly add. But if it's division, you have to find first the percentage uncertainty. So let's find the value first. 0.46, for example. Uh, 0.46 divided by 5. It's gonna be in here 0.092, for example, ya. And then the percent plus minus how gitu kan. Plus minus how, again you have to find the percentage of uncertainty first. Let's first find the percentage of uncertainty of this we'll call it delta m, the zero mass, this one. That's gonna be uh, remember the percentage of uncertainty is it's uncertainty divided by value, so 0.02 divided by 0.46, okay, times 100%. Remember, so this divided by this. Okay, now next up, the uncertainty of this, the percentage will be uh, its own uncertainty 0.01 gram divided by 5 gram, because the value is 5 gram times 100%. Okay, so then you go, let's see, 0.02 divided by 0.46 is actually in here is 43%. That's quite huge, yeah. And then in here is 0.01 divided by 5. It's gonna be 1, 2. This is actually 1, 2, 0.2. 0.2%. So after you got this percentage, then you can use this to calculate the uncertainty in the in the result. So it's gonna be the additional, so it's gonna be, the total is 43.2%. So you go in here 0.92, the result of this. The uncertainty is plus minus 43.2%. So that's the percentage. If you want to find the absolute, then you just need to, like, okay, 43.2% times 0.092. So it's gonna be 0.092 plus minus the absolute-nya 0.0397. Usually we round it up into 1, 0.092 plus minus 0.04. So that's gonna be the uncertainty, the final uncertainty. So that why the range, it will be ranging from let's see, 0.04 plus 0.092 is 0.132 until 0.092 minus 0.04. It's gonna be 0.0352. So yeah, that's the thing. Okay, in recap, the uncertainty of measurement is available written in the apparatus, usually in the book, in the manual book, or in the for example, the scale itself, and it show to you the range of the value that they produce. Usually the writing will be plus minus. It means the value of your measurement plus the uncertainty, and minus uncertainty. there are two types of uncertainty in here, the absolute and the percentage uncertainty. Absolute is the actual number, when the percentage of uncertainty is the absolute number, absolute uncertainty divided by the actual value times 100%. So in here is, for example, the absolute is 0.01 and your measurement is 5 gram. Then you go 0.01 divided by 5 times 100. If your measurement is 10 gram, then the percentage will be 0.01 divided by 10. So that's the percentage of uncertainty. The second one is propagation of uncertainty. If you have addition and subtraction, like addition, this is subtraction of initial minus final mass, then the uncertainty is added. The absolute uncertainty is add up. Then in here you can see that, okay, I have weight and then heat and reweight, and then initial minus final will be 0.46. The uncertainty will be total of both mass, 0.01 plus 0.01. But if you have a division or multiplications, it's going to be a little bit more extra works, because you cannot directly total the absolute uncertainty, but you have to find the percentage of uncertainty first. For example, in here, if I want to divide my 0.46 with the initial mass, then 0.46 has the uncertainty of 0.02, as we had before. 5 gram is 0.01. You cannot add up this directly. 0.02 plus 0.01 cannot, but you have to calculate the percentage of it one by one. So the upper side, the percentage will be 0.02 divided by the value 0.46, and the bottom side is 0.01 divided by the value, then times 100, and then you will have this 43% and 0.2%. This is the percentage of uncertainty of each, and then after you have the percentage, then you can add up. So 43 plus 0.2 is going to be 43.2%. But if you want to go back to the absolute uncertainty, then just multiply this with the actual value. So 43.2% of 0.092 is going to be 0.0397. We usually round it with one significant figure. So it's going to be 0.04. So the value of this 0.092 will be plus minus 0.04. That's all. I think that's complete all the uncertainty calculations. Later on, we will go to the sample of calculations discussion. Right, guys. Thank you. Bye.